Consider the decomposition of BaO2 to BaO in oxygen gas. Which of the following is false? A. BaO2 is oxidized. B. BaO2 is reduced. C. Barium is oxidized. D. Oxygen is oxidized. Or E. Oxygen is reduced. If we refer to a periodic table, we will find barium in group 2A. It is an alkaline earth metal. Since barium is a metal, we expect compounds of barium to be ionic. Therefore, we expect both BaO2 and BaO to be ionic compounds. We also know that the cation in BaO2 and BaO is a monatomic barium ion with a charge of +2. We know this because when group 2A elements form compounds, they are always found as monatomic ions with a charge of +2. Oxide, the ion formed when oxygen gains 2 electrons, is the only monatomic ion of oxygen that's found in nature. The sum of the charges of the ions in one formula unit of an ionic compound should add up to 0. Therefore, in BaO, the negative ion must be oxide. In this case, one formula unit of BaO would consist of one barium ion and one oxide ion, and the sum of the charges would be 0. +2 plus -2 is 0. Compounds are neutral, so the charges in a formula unit must add up to 0. In BaO2, the negative ion can't possibly be oxide. If it is, then we are looking at a formula unit consisting of one barium ion with a charge of +2 and two oxide ions with a charge of -2. The charges would add up to be -2. We do know that oxygen atoms can form a diatomic ion called peroxide. The anion in BaO2 must be peroxide. The sum of the charges for one barium ion and one peroxide ion is equal to 0. In other words, BaO is barium oxide and BaO2 is barium peroxide. To determine whether something is oxidized or reduced, we must determine oxidation numbers. By now, you should know how to do this. For elements in the reactant, the oxidation numbers are +2 for barium and -1 for oxygen. For elements in the products, the oxidation numbers are +2 for barium and -2 for oxygen in BaO, and 0 for oxygen in the diatomic oxygen molecules. Oxidation involves an increase in oxidation number. We can therefore conclude that oxygen atoms in barium peroxide, which have an oxidation number of -1, are oxidized and end up with an oxidation number of 0 in diatomic oxygen molecules. Therefore, choice D is true. Oxygen is oxidized. Choice A is also true. Since the oxygen that is oxidized is in BaO2, we also say that the BaO2 is the substance that is oxidized. Reduction involves a decrease in oxidation number. We can therefore conclude that the oxygen atoms in barium peroxide, which have an oxidation number of -1, are also reduced and end up with an oxidation number of -2 in barium oxide. Therefore, choice E is true. Oxygen is reduced. Since the oxygen that is reduced is part of BaO2, we also say that the substance is reduced in BaO2. Therefore, choice B is true. BaO2 is reduced. Let's see what we have so far. Oxygen atoms in barium peroxide are oxidized and reduced at the same time. We can also say that the peroxide ions in barium peroxide are oxidized and reduced at the same time. The substance itself, barium peroxide, is said to be oxidized and reduced at the same time. When the same substance is oxidized and reduced in a reaction, the reaction is called a disproportionation reaction. Anyway, we have one remaining choice that must be false. Choice C must be the correct answer. It must be the false statement. Indeed it is. The oxidation number of barium is +2 before and after the reaction. Barium is not oxidized. In fact, it is neither oxidized nor reduced. If you find yourself confused in asking how an atom can be both oxidized and reduced at the same time, here's a clarification. An atom cannot be oxidized and reduced at the same time. You need to realize that a typical sample of barium peroxide contains a gazillion oxygen atoms, not just 2. What we really mean is that some oxygen atoms are oxidized to diatomic oxygen molecules, and some oxygen atoms are reduced to oxide ions. In fact, the balanced equation tells us that for every 2 atoms that end up in oxide ions, another 2 oxygen atoms end up as a diatomic oxygen molecule.